MBA633 instructional video created by Professor Ahmed Dada, School of Management, George Mason University. In this video clip, we will be discussing descriptive statistics, primarily measures of location. And the basic idea behind measures of location is to tell us where certain values for common positions in the data are located. For instance, a very common measure of location is where is the middle of the data. The basic idea behind descriptive statistics is to convey in a parsimonious fashion what are the patterns of values in the data, instead of giving a user tons and tons of individual data values, to somehow summarize them quantitatively in a way that the user can visualize what are the pattern of values. And one of the most common measures of location is where is the middle of the data. There are other measures of location also, but then we will discuss that gradually. But the most common one by far is where is the middle of the data. And again, when we say middle, there are different ways to measure the middle of the data. And the most common one is what is called the mean or the average. In this example, we have data on 111 starting salaries for 111 students. So these are starting monthly salaries, as you can see in this column. In column C, all I've done is taken the starting salaries and sorted them in ascending order, so just ignore that for a moment. So the raw data here consists of one variable for 111 elements. Remember the definitions that we had before, all the starting salaries. So how do we compute the middle? How do you compute the mean of the salaries? So the mean of any data variable is simply the sum of the values divided by the number of values. Based on this calculation, you can see that the data has to be quantitative and ratio scale, otherwise it's not going to make much sense. So sum of values divided by number of values. So let's do that here. So the built-in function in Excel for computing the sum is just sum. So I type in the built-in function and I highlight all 111 salaries. So there you have the sum, which is $404,065, and the number of values that we have in the data set. Of course, I could manually count it, but there is a built-in function to do that as well, which is count. So I count the number of values, which should come to 111, of course. Okay, so there you have 111. So the mean or the average is simply the sum of the values divided by the total number of values, which is $3,640.22. Now I showed this to you in longhand over here, the manual way for doing it. In Excel, you obviously don't have to do it manually. There is a built-in function in Excel to compute the mean or the average for you, but I wanted you to see how it's done. So the built-in function is average, and you simply highlight the values the set whose average you want to compute. So I have highlighted all 111 values here, and I should get exactly the same number, which is $3,640.22, as you can see. So the built-in function and the manual calculation did and should give exactly the same value. Now, the reason I showed this to you is to point out now the weakness of the mean. In other words, the way the mean is calculated, particularly the fact that all the values are added up, means that it's extremely vulnerable to one or two outliers. For instance, if this first student, instead of having a monthly salary of $3,330, let's say this student had a monthly salary of $33,000. He went on Wall Street and made a lot of money. So just one student has 33,000, and you can see that immediately made a big difference in the average salary for the entire data set. It's now gone up from 36 to 3,900 as the average, you can see over here. So an extreme value, one student has the ability to create a significant difference in the average. And this is a distortion, as you can see, because the bulk of the values are not around that. So the mean is very vulnerable to extreme values. It's okay when there are no extreme values, but if there are, then it can be vulnerable. In other words, it can misrepresent the middle of the data. Now, the median, by contrast, was designed to compute the middle of the data in a way that is less vulnerable to such extreme values. And the definition of the median is, it is a value such that half the values are less than it and half the values are above or greater than. So clearly there is we have to start conceptually by thinking and considering that these values are first sorted. So let's conceptually, what I've done in column C, I've taken the same salaries for these 111 students and just sorted them in ascending order. So when I want the median, I'm trying to compute or determine what is the salary such that half of the students made less than this salary and half the students made more than this salary. Okay, so clearly I have to start with the number of students that I have, which is 111, and where is the middle? In other words, what is the index for the middle value? And the index is simply 111 divided by 2. In other words, what I have to do is look at this sorted list and find the 55.5th student. That's where the middle is. There are 111 students, so half of that is 55.5. So I have to look at the 55.5th value, which clearly doesn't exist. Okay, so on the list, so we'll round it up to 56. Okay, and I look for the 56th value. So if I scroll down a little bit, where is it? Oh, scroll down too much. Here is the 56th value. So you can see it's 3,645 in the sorted list. So based on my manual calculation, I see that the median is $3,645. Okay. Now, if you had a large data set, it would be troublesome to do all this manual sorting and eyeballing as to what the middle is. There is fortunately a built-in function in Excel to compute the median, and the built-in function is itself called median, as you would expect. So I simply highlight, I rather type in the built-in function median, and I highlight the data. Notice that I do not have to pre-sort the data in order to apply the built-in function. I'm highlighting the unsorted data, as you can see. So let's see if we get exactly the same number here. So there you go, $3,645. That's the built-in function. Okay, now I'm going to do the same thing again that I did a few minutes ago. In other words, change the salary for this first student from 3,330 to, let's be more generous this time, let's do 333,000. So he made it really big on Wall Street. So this one student got a monthly salary of $333,000. Now what I want you to do is notice what effect this has on the mean and the median. As of now, the mean is $3,640 roughly, and the median is $3,645. So as soon as I do this one student making that huge amount of money, you can see that the mean jumped from 3,640 to $6,610, giving a completely inaccurate picture of the pattern of values in this data set, whereas the median didn't. Median remained at $3,645. So you can see that simply because of the way in which these two metrics are computed, one is much less sensitive to extreme values compared to the other. And that is exactly why when housing prices are published in newspapers, they usually report the median house price, not the mean house price, because it's simply a fact of life that in any neighborhood there will be a few very overpriced houses, not overpriced, but houses that are much more expensive than most, and there will be a few that are much cheaper than most. So they tend to report the median for that reason. Okay, so let me correct this value back to 3,330, and all is well with the world now. The average $3,640 and the median is $3,645. So there you have the two most common metrics for computing the middle of a data set. And the middle of the data set is a very useful way to compare, is very useful for comparison. For instance, if you're trying to determine is one neighborhood richer than another, you could compare the means salaries of the two neighborhoods, for example. If you want to determine whether housing is more expensive in one neighborhood compared to another, instead of looking at 100 prices in the two neighborhoods separately, you might just compare the average rental prices in the two neighborhoods, or the average house prices in the two neighborhoods. So the central location here, the middle of the data, whether you use the mean or the median, is a useful proxy for the entire data set, and it's fairly commonly used for comparison. Is one country richer than another? Are people, have they gained weight? Have people become heavier compared to 10 years ago, etc., etc.? So the middle of a data set is a very common descriptive statistic that is used to characterize a data set.